Hello everyone, welcome back to my YouTube channel. In this video, I want to solve the next 3 questions from EJU Physics 2018 second session, which is question number 4 until question number 6. You can check link on the description box below if you want to watch the solution for the other question in this paper. Or don't forget to check my EJU playlist for another past papers of EJU. Okay, let's start for question number 4. In this question, we have a small object A of mass m is traveling at velocity v1, as you can see in the diagram below. This is object A, the mass is m, the velocity is v1, and it collides with object B. It will collide with object B. We do not know the mass of object B, and we do not know the initial condition of object B. I mean, we do not know at initial object B is moving or not. And then after the collision, the velocity of A changes to v2. So this is the initial condition of object A. This is the final condition of object A. Let us denote F delta t, the impulse imparted to B. You have to be careful of this. F delta t is the impulse to B by the collision. From 1 until 4 below, choose the figure that correctly represents the relationship of F delta t with mv1 and mv2. To solve this question, you need to remember the relationship between momentum and impulse. If I try to recall it, the change in momentum is equals to impulse. So our formula is change in momentum delta P, I use P for momentum, is equals to impulse. The formula of impulse is F times delta T. So F delta T here is the impulse. So delta P, or change in momentum, is equals to F times delta T. To find change in momentum, I can use final momentum minus initial momentum. If you remember the concept of vector, to calculate change in momentum or change in a vector quantity, we can use final vector or final momentum, in this case, minus initial momentum, equals to F times delta T. So, if I want to find F delta T, I need to draw final momentum minus initial momentum in a vector diagram. I repeat it once again, yeah. If I want to calculate or to know F delta T, I need to draw vector diagram final momentum minus initial momentum. From the option below, I will try to use this. As you can see, my red highlight as mv2. mv2 is the final momentum. You have to remember, yeah, the formula of momentum is equals to m times v. So mv2 is the final momentum. So this is my final momentum. I write it down as mv2. And then I will use another color, let's say this blue one, as an initial momentum. So this blue arrow is an initial momentum, mv1. If I want to draw final momentum, which is this one, minus initial momentum, which is this one, in a vector diagram, I can draw it something like this. Start for the final momentum first. This is the mv2, this is the final momentum, minus initial momentum. If we want to subtract two vector quantity, we need to change the direction of the second one, which is initial momentum. This is positive initial momentum. So if I want to draw negative initial momentum, we need to change the arrow. So I think something like this. I will copy it first, and then like this, and then this is negative mv1. So this is our final momentum minus initial momentum is this one. Then the resultant of P final minus P initial, which is the resultant of this vector diagram, is F delta T. So my F delta T, or the resultant, is this one. This is F delta T. F delta T. But our final answer is not number 1. As you can see, the F delta T pointing this way. So from my diagram, maybe you will think that the final answer is 0.1. But in fact, the final answer is not 0.1. Why the final answer is not 0.1? Because when I when I draw this vector diagram, I consider the initial and final momentum for object A. As you can see, m is the mass of object A, v1 and v2 are the velocities of object A. So this is the impulse of object A, not object B. That's why I highlight this sentence. So to find the final or the impulse of object B, as they ask, we need to oppose the direction. When object A in contact with object B, object A will exert force to object B. At the same time, object B will exert force to object A. That's the example of action-reaction force. This is Newton's third law, yeah? In action-reaction force, or in Newton's third law, the action always opposite direction with the reaction. So, if you want to find the impulse to B, the direction is opposes the impulse to A. So, since this is a diagram of vector of object A, if we want to find impulse to B, the F delta T must be in opposite direction. That means the correct answer is number 2. So my final answer for question number 4 is option 2. Okay, let's move to the next question, question number 5. In question number 5, we have a lightweight inelastic string of length L. This is the string of length L, is fixed in place, and a small ball of mass m is attached to the other end and suspended. So this is the fixed point, and then the other end we have a ball of mass m. The ball is made to undergo uniform circular motion. So the ball will move in uniform circular motion within a horizontal plane, where the pulling force exerted on the ball by the string, which is the tension in the string, is equals to 2 mg. Let us denote as omega the angular velocity of the ball's circular motion. And then they want us to find omega in terms of G and L. We want to find the omega in terms of G and L. Basically, omega is the angular velocity. Since I have a circular motion, so we can start from the basic of the circular motion, which is net force or net centripetal force is equals to mv square over r. M is the mass of an object that performs circular motion. V is the tangential velocity. R is the radius of the circular motion. And then this one is the centripetal force. If I want to relate omega, we can comes from the formula V equals to omega times r. This is the relationship between angular velocity with tangential or linear velocity. So, if I substitute this formula into that, I can get net of centripetal force is equals to m times, I can substitute V into omega r being squared. So I got omega squared r squared over r. That means net of centripetal force is equals to m omega squared times r. Remember, we want to find this omega. Next thing is, what is the centripetal force? You have to remember that centripetal force is the center seeking force. So if you want to find the centripetal force, you need to see from the free body diagram. We will draw the free body diagram later. From free body diagram, you need to see which force that is directed to the center of circle. Okay, if I try to draw free body diagram for this case, of course we have weight which is vertically downward. This is my weight or m times g, and then I have tension here. The magnitude of the tension is 2 mg. So I have tension here 2 mg. As you can see from this diagram, the force that provide the center seeking force or the centripetal force is this one, because you can resolve 2 mg into the horizontal direction. This is the center seeking force, which is centripetal force. Of course, the other direction is mg, vertical direction of 2 mg. Yeah? This is the vertical direction. If I want to resolve forces, of course, I need to know angle. I will assume theta is here. Let's assume theta is here. As you can see, if theta is here, that means this one is 2 mg cos theta. 2 mg cos theta. And then the centripetal one or center seeking force is 2 mg sin theta. That means I can substitute centripetal force as 2 mg sin theta. 2 mg sin theta is equals to m omega square times r. I think I will substitute the radius by using or in terms of L, but let's do it later, yeah. So leave it R like this. I can cancel out M here, and then to find sin theta, you can see from the vertical component. Since the object undergo uniform circular motion within horizontal plane, that means there is no change in level of this ball. That means to mg cos theta must equals to mg. Or I can write down as net Fy equals to 0. Resultant force in vertical direction is equals to 0. So that the ball will undergo horizontal circular motion. I will assume to mg cos theta as plus or positive sign. So mg is -1 because they are in opposite direction. To mg cos theta minus mg equals to 0. You can divide all the terms by mg, so I can cancel out mg here. 2 cos theta is equals to 1. 1 here, if you move it to the other side, you got 1. That means cos theta is equals to 1 over 2. Cos theta is equals to 1 over 2, that means theta is 60 degree. So I know that theta is 60 degree. So sin theta is sin 60. Now I need to know r, the radius of the circular motion. To find the radius of the circular motion, you can analyze this right angle triangle. As you can see, if this angle is theta, that means angle here is also theta because this is an alternate angle. So this is also theta. And then you know the hypotenuse is L. You want to find the radius. This is the radius of the circular motion. By using simple trigonometry, I can use sin theta is equals to R over L. Sin theta equals R over L. That means R is equals to L sin theta. If I substitute it here, I will get 2g sin theta is equals to omega square times L sin theta. I think after I substitute it, I just realized that sin theta will cancel out. So I think we do not need this one, since sin theta is cancels out. Then I will get 2g equals to omega square L. Then omega square is equals to 2g over L. That means omega is equals to square root of 2g over L. Then my final answer is number 2. This is the answer for the question number 5. Let's proceed to the last question that I will discuss or I will explain in this video, which is question number 6. For question number 6, we have a small object that is undergoing simple harmonic motion on x-axis with the motion centered at the origin x equals to O. So the origin is x equals to O. The amplitude and angular frequency of the simple harmonic motion are 0.5 meter. This is for the amplitude. And then the angular frequency is omega. The omega is 1 radian per second. The question is, what is the object's acceleration at the instant when it passes through position x equals to 0.1 meter? So we want to find the acceleration, where the positive direction of acceleration is the positive direction of the x-axis. So basically we want to find the acceleration of an object that is undergoing simple harmonic motion. If you remember the formula of simple harmonic motion's acceleration, in simple harmonic motion, acceleration is equals to negative omega square times x. By the way, this is the definition of simple harmonic motion. Simple harmonic motion is a motion that has acceleration that is directly proportional to the displacement but in opposite direction of displacement. So I think by using this equation, we can find the accelerations of the object. Just substitute the omega is 1, times displacement. The displacement is positive 0.1. So just put it positive. Then my final answer is negative 0.1 meter per second square. So question number 6, I think quite easy, yeah. Just use this equation, then we get the final answer. So the final answer is 3. Okay, this is the end of this video. Thank you very much for watching this video till the end. I hope I see you guys on my next video. Thank you and bye bye.